Welcome to Brain Vision.
Here we have a man pushing on a piano that is basically, they says, it slides constant down a ramp. I'm assuming that he's pushing to keep it from sliding down, and he's losing that battle, I guess. So the piano weighs 180 kilograms. The ramp is at an angle of 19 degrees with the horizontal. And so they ask us what the force is that the man must apply if he applies it parallel to the ground, or parallel to the ramp, or parallel to the ground. So we have F and F prime. Now, because it's a constant velocity, this is still in, it's still a statics problem. There's no acceleration in this case. So we have, in the first case, when he's pushing horizontal to the ramp, we simply have, doing a force balance in this direction, we have F equals W sine of theta. W is mg. Plugging everything in, we get 574 newtons. So if he's pushing this way, he needs 574 newtons. Now, in the other case, we basically, I took force balances in the horizontal and the vertical direction. In the horizontal direction, we have F prime equals n sine theta, and in the vertical direction, we have n cosine theta minus W equals 0. So n equals W over cosine of theta. Plugging this into here, we get that F prime equals W times the tangent of theta, which is mg times the tangent of theta, and plugging in, we get 607 newtons. And it should make some physical sense that this is greater than this, because here he's actually pushing, some of his force is actually going to push this into the ground. Now, if there were some coefficients of friction here, then that would that would aid in the friction force, because this normal force would be greater in this case than in the previous case. But in this case, basically, because we're not worried about that, he's basically not, all of his effort is not being directed at keeping this thing in equilibrium along this direction. Or at least keep it from accelerating in that direction. And you can see here too that sine of theta and tangent of theta, actually, both sine of tangent and sine of theta and tangent of theta, for small angles, they both have an approximation of theta. What theta would be in radians. So you can see that they're pretty close, because 19 degrees is not particularly small, but as we get down to 0, then they both go to 0, obviously. And for if theta was very small, these things, as theta gets smaller, these things get closer and closer together.